Have you ever wondered what's really going on inside the brain of someone who's, exceptionally smart? We're not just talking about knowing a lot of facts. We're talking about the actual architecture of intelligence. What's the design? What's going on under the hood?
So, what really makes a mind smarter? Is it just about having a bigger brain? I think we all kind of know that's not the full story. The real answer is so much more fascinating, and that's what we're going to dive into.
To really get it, we're going to peel this onion back layer by layer. We'll start with the physical hardware, the brain itself. Then we'll look at the software it's running and how that changes the way people think. We'll even explore the inner experience, what it feels like. And finally, we'll zoom out and put it all in context.
All right, first up, the actual wiring. You can forget that old idea that a bigger brain is always a better brain. The real difference, it turns out, isn't about the size of the engine, but about how incredibly efficient it is. It's a total design upgrade.
This all comes down to something called the neural efficiency hypothesis. Here's the wild part. When you give a high IQ brain a moderately tough problem, it actually lights up less. It uses less energy. It's like a finely tuned sports car engine that gets incredible performance while barely sipping any gas. It's not about neural brute force. It's about biological elegance. So where does this efficiency come from? Well, for a long time, we thought it was just about having lots of connections between big brain regions. But the latest research shows that's not quite right. The real secret sauce is in the fine-grained wiring. These super specific, precise connections that allow for incredibly clean information processing. And this precision wiring matters most in two key networks. You've got the frontoparietal network, or FPN. Think of this as your brain's CEO. It's the control center that's managing whatever you're focused on right now. Then there's the default mode network, or DMN. This is your inner world, the part that lights up when you're daydreaming, planning for the future, or just thinking to yourself. Better wiring in these two spots means better thinking pretty much everywhere else.
Okay, so if that efficient wiring is the upgraded hardware, what's the software that's running on it? Now we're getting into the core cognitive functions that really drive intelligent thought.
First up is working memory. The best way to think about this is like your mind's temporary workbench. But here's a really crucial detail from the research. Being smarter isn't about being able to see a few items on your workbench in super high definition. It's about being able to fit a greater number of different items on the workbench at the same time. It's about mental bandwidth, not resolution.
Then you have executive attention. If working memory is the workbench, executive attention is the conductor of your entire mental orchestra. It's that top-down control that's telling you what to focus on, what to ignore, and when to switch gears. It's the manager in your head that directs all your other cognitive tools.
For a long time, we thought raw processing speed was the key to intelligence. But it turns out, while speed helps, executive attention, that ability to control your thoughts, is way more fundamental. There's this thing called the worst performance rule, which found that how you handle your slowest reaction times, usually when your attention slips, is actually a better predictor of intelligence than your fastest ones. It's the quality of control that really truly matters. So, we've got this super efficient hardware and this powerful cognitive software. What does that actually produce? How does this whole setup change the way a person thinks and tackles problems out in the wild? One of the biggest outputs, maybe the biggest, is superior pattern recognition. This is the ability to look at what seems like a total mess of random data and just see the structure, to see the hidden rules and connections. This is the bedrock of abstract thought, being able to pull a concept from one situation and apply it to something completely different.
Now here's a fantastic paradox for you. You'd think that smarter people would be faster at everything, right? Well, they are faster on simple tasks, but research consistently shows that when problems get really complex, they're often slower. And this is so telling. They aren't slower because they're struggling, they're slower because they're being incredibly deliberate.
So what are they doing with all that extra time? They're investing it. They're spending more time up front, breaking the problem down into smaller pieces. They're generating multiple possible solutions instead of jumping on the first one that comes to mind. They're gathering evidence and systematically checking each path. It's this methodical process, which their cognitive engine allows for, that leads to way more accurate answers in the end.
Of course, this unique way of thinking doesn't just switch off when the problem is solved. It fundamentally shapes a person's entire inner experience. And this powerful mental engine, well, it can be a real double-edged sword. This quote just hits the nail on the head. That amazing brain, built for complex analysis and future planning,
When it doesn't have an external problem to chew on, it turns inward. And that same power can be used to imagine in excruciating detail all the ways something could go wrong, or to endlessly replay a past mistake.
And look, this is not just a vague idea. The data is pretty startling. One major study of Mensa members found that their rates for diagnosed mood and anxiety disorders were more than double the general population. There's a real, documented link between this cognitive style and a higher risk for certain mental health challenges.
Now, this often gets twisted into that old myth of the brilliant but socially clueless genius who has zero emotional intelligence. But the reality is much more interesting. The evidence just doesn't show a trade-off between IQ and EQ. A better way to frame it is as an interface problem. It's a mismatch between a brain that wants to analyze everything deeply and a social world that often operates on fast, intuitive, and unspoken rules.
And that interface problem can lead to some very real struggles. Crippling perfectionism, because you can always imagine a better outcome. An intense fear of failure, especially when everyone has labeled you the smart one. A heavy burden of potential. And yeah, sometimes a deep sense of social isolation when it feels like nobody's on your wavelength.
And this brings us to a really crucial final point. Everything we've talked about is centered around what IQ tests measure. And while that's a powerful tool, we have to remember it is not the whole story of what a human mind can do. Not by a long shot.
So let's just bust one of the biggest myths right here and now. A high IQ is not a golden ticket to success. It just isn't. Sure, it helps with certain things, but real-world success is a messy equation with tons of variables. Grit, curiosity, social skills, motivation, and yeah, a healthy dose of pure luck.
In fact, many psychologists argue for multiple forms of intelligence. Analytical intelligence, that's IQ, is just one piece of the puzzle. You've also got creative intelligence, for coming up with new ideas, practical intelligence, which is basically street smarts, and of course, emotional intelligence, for navigating the complex world of human relationships. Real success in life usually requires a healthy mix of all of them.
So in the end, you can think of high analytical intelligence as being handed a really powerful and sophisticated toolkit. But just like any toolkit, its true value isn't in the tools themselves, but in the skill of the person using them. Which leaves us with a final question to think about. How do we all learn to not just have these tools, but to get really, really good at using every single one of them?